Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to the ninth lecture of computer programming for civil engineers. And today we are going to learn some advanced use of Microsoft Excel, and same will be applied to Google Sheets. So let's start. Uh, let's start with this. And today we are going to learn all that with the help of an example of a lintel beam. So usually when we construct a building, above the door openings and window openings, we provide a reinforced concrete beam, which means there are steel bars inside this concrete beam. And if you cut a section out of it, you can guess it to be something like this. So in this cross section, you can see there are some steel bars at the bottom. These are the steel bars that resist the bending that will occur in this beam. And there are holder bars as well. So there is a shear force produced inside this beam. In order to control that, we provide this all the way around stirrup steel bar stirrup rings, and to hold them together we provide two holder bars at the top. So we need to find out how much steel should we put at the bottom that can resist the bending. We'll not talk about stirrup today, but then holder bars are also they are just for holding them. There is no design for that, so just you need two steel bars at the top. But it is important to design how much steel is required at the bottom to resist the tensile stresses produced at the bottom. So you can consider the load on top of this beam from the brick masonry and the slab above it that comes down on this opening is resisted by this beam, and two reactions are produced at these supports. You can consider it as this uniformly distributed load over this beam, and uh, usually it is uniformly distributed in this way as well. So a shear force diagram like this will have a shear here which is equal to the total load. Let's say if W is 10 and L is 5. Well, for a small door it will be about 3 plus 1 plus 1 foot, which is around 5 foot length. So 3 foot I'm saying is the opening width, and 1 foot support. So let's say it is a 5 foot long beam with certain depth small d, or actually the full depth will be h. But then actually in the design formula we don't use h, we use the distance of the steel bar from the top of the beam, which is small d. And the width of this beam in the cross section is b, which is you can see lightly here as well. And you can see that the maximum bending moment is produced in the middle. Let's call that equal to m, and that bending moment from this load wl, or w load distributed on top, will be wl square over 8. But let's use excel, and in excel we are going to use this example to find out how much area of steel as we need in square inches to be able to resist the load which is causing a bending moment of m at this right in the middle location here. Or maybe if the load is not uniform distributed, the maximum bending moment may be somewhere else. So we'll write a excel sheet that will be able to design this beam for us. So the design formula is the moment which we need to be resisted by this beam should be equal to the a factor phi. Let's not go in detail of that. um, it is a reducing factor, and usually 0.9 for beams, so it will be a constant. As in square inches will be the area of all these steel together. So if the area of one small steel bar here is 0.11 square inches, then all four of them together will be 0.44 square inches, for example. But we don't know that. The question is, let's find that out. Fy is the yield strength of steel, the load at which it yields we will consider it equal to 60 kips per square inches. D, as I already have explained, is the depth of the steel bar centroid from the top fiber, and minus ASFY, same as we discussed. FC prime is the strength of the concrete, the compressive strength of concrete, usually taken as 3000 psi or 3 ksi for a typical concrete, which is mixed in the ratio of 1 to 4, which is one volumetric portion of cement, two volumetric portions of sand, and four volumetric portions of aggregate inside it. And B here is the width of this beam. So if we put all these values in the formula with 1.7 as a constant and phi as a constant of 0.9, we will find out that this beam with this many steel here can resist how much of the moment. And if the resisting moment is greater than the applied moment on this beam from the brick masonry and slab from the top, that we'll calculate here as WL square 8, for example, then we say this steel is good. But if the strength of this beam with this steel is the movement which is very large compared to which is actually applied on it, then it will be a very uneconomical one. We should reduce the amount of steel in it, and this is called designing. So we'll use this example in Excel to learn how we can do advanced things in Excel. So let me run Microsoft Excel by just simply typing here EXCEL, because I've already installed Microsoft Office 365. All UET Peshawar students can install Excel from HEC website. If you have any problem in it, you can contact me and I can help you in downloading that as well. So today, because we are learning it, so let's start with a blank workbook. So we'll click on blank workbook. So once we are in a blank workbook, this is something that we'll see on the screen. All these small boxes, if you click them, you will see that they get selected. They're called cells, and you can type anything in any cell anytime, but just by clicking. You can also click and go to the formula bar here and type whatever you want to type there and press enter to let it be typed. So this all is an arrangement of cells in the form of a grid. So what I just did now, I already had written so many things. I clicked on one cell and dragged it with the mouse and selected the area where I wrote all these things, and press a delete button to remove them all. And then I'm just clicking anywhere else, and I can keep working now. So this is the group of cells is called sheet. So this is one sheet, and you can see the name of this sheet is sheet 1. You can double click it and name it anything you like. For example, lintel beam design. And if you want to add more sheets, you can click on this plus symbol here, and it will add another sheet for you here. And if you click this tab, you will go back to the previous sheet. The rows are named by numbers starting from 1, and if I click um, control down here, it will take you to the last row, which is about 1,048,576th row. So there's this huge number of rows here in Microsoft Excel 365. Let me click control up arrow key to go back to the um, first row. Also the columns here are not numbered but alphabetically arranged. There is a setting here in Excel that you can change this into numbers as well, but then let's not go in that detail today. But if you are interested, you can search for it and you can change it to numbers too. But to get rid of confusion, better keep it as alphabetical. So I click anywhere on second row, for example, and press control and then right arrow key. It will take me to the last cell here, which is alphabetically XFD. So what happens here, I clicked control left now to come back to the first column. So alphabetically, once it starts all the way from A to Z, then next it starts with A B, A C, A D, A E, and so on. And then once we are at um, AZ, so then we start with BA, BB, BC, BD, and this is how these columns are named. And these names are the references of these cells. So for example, if I write my name here in column C, row 5, and I want in J13 that whatever is written in column C5 should also come here, so I'll press equal symbol here, so I'll write equal here. So whenever we write equal in Excel understands that now I'm going to enter a formula. So you have noticed that whatever I've typed before this, I never used equal sign, or sometimes also plus symbol is also used instead of equal, but it's fine to use equal mostly. So uh, whatever I wrote before, I never used equal sign, so Excel was not giving me any warning. But now after this, instead of writing a formula, if I write anything else and press enter, it is considered as a wrong formula and name error will appear here. You can see it is with green warning. If you bring your mouse over it, you will see a warning symbol and it says the formula contains unrecognized text. If you click it further and you want to ignore the error, or you want to if the, correct this error, you want, there are so many other settings that we can use, but let's not use them now. So here my current plan is, I want whatever is written in column C, row 5 should appear here. So I will write equal and then I'll write column C and I'll write row 5. So C5 is the address of that cell. You can see as soon as I wrote 5, it got highlighted there. So if I write C3, C3 cell got highlighted there. Now I delete that and write C5, and once now I press enter, whatever is written there appears here as well. So if I change this to M dot space ADIL and press enter, you will see because it is reference to it, it automatically changes here. So if I change it to a number, for example 100 or 1000, and press enter, so it is accepting it in that way. So we have learned that to enter a formula in Excel, you always have to start with an equal or a plus symbol. So again, for example, plus C5 and press enter, so it works the same way. So I select all of them and press delete key. So now my sheet is clean again. So let's start with our example that we planned to work on it here. So the example is this lintel beam design, and the question is that we need to find out what is the maximum movement in this beam, which obviously is in the middle, but let's assume we don't know that. So we'll use Excel to find that moment. And once we figured it out, the question is how much steel we should put at the bottom, which area it will be AS. So in square inches, we'll figure out how much steel we need in this beam. And once we know that, the design will be complete and we can carry on with the construction hopefully. So first of all, let's notice the length of this beam is L, and we know it is currently 5 feet from edge of the support to the other edge of the support, let's say, and we'll use 5 feet for that purpose. There, of course, you should take a center to center distance from here. So, well, okay, we'll use that. Why not? So let's start by actually writing all variables here. So here for um, as a Excel sheet developer for my own understanding or clarification, and if anyone else is using my Excel sheet for their clarification, let me write some titles so that people know where to write what. So I want people to write length of the beam here, so I just make it a little bit beautiful by writing equal sign here at the end. So now people will know that there is length equal, and equal to what they don't know, so they should write the length here. So for example, in our case, currently this length is 3 feet, and this is 1 foot, and this is 1 foot more, so total length is 5 feet. But from support center here, if you leave 6 inches from here, and on the other side if you leave 6 inches from this side as well, so total you are left with 6 inch plus 3 foot plus 6 inch, which will be all together 4 foot, so 4 feet. So let me write 4 here, but if I write feet with it, I can actually write anything with it, 4, anything with it. So this is not considered as a number by Excel. So let me increase the size of the menu here. You can notice that once I click here, it is the format of whatever is written here is selected in the home tab. Inside this number, it is actually general now, so we can write literally anything here. But if you specifically want to write numbers here, then now it is going to accept numbers, but let's keep it general because it has the ability to write anything. So what I'll do, I'll keep number here as 4, and I'll write a unit for my understanding as a text feet, and press enter. So here we have a number, here we have a string, and here we also have a string. We can write anything here, but this is something that can be calculated with. So for example, if I want to double it here, I can write equal, and then instead of writing C3, I can actually also click here. So now C3 is automatically written here. If I say shift 8, which gives me asterisk for multiplication, and multiply it with 2 and press enter, now the formula will run and it will multiply it with 8. So instead of 4, if I would have written 4 feet here, even with the space for example, and if I press enter, it will give me a value error, which is understood by Excel as a value is used in the formula is of the wrong data type. The Excel is expecting a number to be multiplied with a number, not a string to be multiplied with a number. So we know what is the correction required, so we will keep it clean as number like this. Also, if you by mistake and put any space in it, sometimes it or space behind it as well, so it starts not understanding it as number in some old versions, and it start giving you some errors. So be careful about it. So for now, let me keep it clean by removing all spaces and write a number here. So let me delete this number from here now, and let me delete this as well. So in order to make it more visible to the user that this is a place where we need to put some data, why not let's identify it more visibly by giving a background color to it. So let me give a good background light color here, maybe this green color here, and let's put other variables that we need as an input here. So we also need after the length, we need the depth of the steel bar. We also need the width B of the beam, and all of them are in inches. So for the user, I'm just writing in as inch for them, that they need inch here. Now if I've written something here or made a format here like this, and I want to apply this format somewhere else, specifically if I want it here for example, so what I can do is I can click here, and if you notice there is a small box at the bottom here, right here. So if I grab it with this box in the bottom right and drag it down here, you will see that the same format is applied on all these cells, so they are colored now. Similarly, if in as a unit inch is written here, and I want it to be written here again here, instead of typing it here, I can also click and drag, and it will get converted into in here. automatically a copy of it, and as many copies as I need, I can quickly make them by dragging them like this. So let me Control Z and undo it. I need it up to this range. Also in Excel, if you write two numbers, for example 1 and 2, and select them together, and then if you drag them together like this, it will auto increment all other numbers with the same increment of the first two. So for example, if the first number I wrote as 1 and the other is 1.5, now the increment is not 1 but 0.5. And if I grab them and drag them, select them and drag them, now you notice with the same increment of 0.5, it has auto incremented it for us. So this is a very useful ability of Excel. Um, Next, let's put Fy, which we know Fy will be placed by users in the unit of, let's say, KSI, in kip per square inches. Also, Fc prime equal, and also in the units of KSI, kip per square inches. Now if I want this to be formatted, so for example superscripting and subscripting, I can do that by selecting this text, going in the formula bar, selecting the portion I want in subscript, and then right click on this, go in the format cell, and in here I select subscript and OK. So this C will get subscripted. I can repeat the same with Y here. In Fy, right click, format cell, and then subscript, and then OK. So we can do so much editing in it by using the tools available in the font area here. I can now drag this as a blank here. Now they seems mixed, and they seems all together is a single box. So in order to give them a border shape, I select them and I give them all borders everywhere. So now they look like boxes where we need to input some values. So we have everything required in this formula except m and phi. So let's write phi here as well. For phi, we can actually write, there are several ways of writing symbols here. So we can actually go in insert, and in insert we can click on symbol, and then in symbol we'll have a huge set of symbols, and then you can choose among them. You can scroll and search for them. It can be a hectic for you, but then quickly what you can do is you can go in the font, you can select symbol from here, and you click, it will give you quickly the Greek symbols, and then you can select 5 from here and say insert and close. So here it got inserted, and now you can write equal here, and then carry on writing in it. Also another way of doing that is you can instead of writing that, you can write F for phi, but then select the F and change its font to symbol, SYMBOL. Here it is at the bottom. So select it, automatically its font will change, and then you can write equal sign in front of it, and then we know it's a constant. So let's write the constant directly. Now let's input some values here and then use them to find out moments. So the length we already know it was 4 feet. Depth, let's assume it to be 1 foot or 12 inches deep lintel beam. The width, let's imagine the wall is 9-inch thick, so the width should be 9-inch as well. So 9-inch wide beam. Fy, we decided it should be 60,000 psi or 60 ksi, and Fc prime is 3. Fc prime is 3. So now we can actually write this formula to calculate the movement capacity of this beam, and then we can compare it with the length. But what's missing is AS, the area of steel. So this is something we need to calculate. So I've just written it separately. Let me select S here and quickly right click on it and convert it into a subscript. This is the final design result. So let me give it a different type of a background color, because it's an output. Let me give it border as well, and we know the units should be in square inches, and in here the square, in order to make it superscript, I select, right click, format cell, and superscript it, and OK. So let me use the other sheet 2 to draw bending moment diagram for it and find the maximum moment applied on this beam. So let me double click and say BMD, bending moment diagram, and here I'll say X, and X in parentheses. I'm just writing that here we'll have X will be in feet. So it is just simply a text, it is not a formula. And then here I'm writing M, moment. So moment will be in K, kip feet. So another thing we need to take as an input here is the load or W applied on top of it. So let it be W equal to the load here, and I'm dragging this up, so it will copy 4 for me there, but now I can change it to 1, and the unit is kip per feet. So now uh, let's write different distances for this length. So at a distance of maybe half foot and half foot, further and further and further, all the way to 4 feet, let's find out the moment. So here I will write uh, 1 I'll write 0 at 0 foot, and then I'll write 0.5 foot, and then I'll select them, and with an increment of all the way to 4, I'll drag it up till here. Now we can do it automatic as well, that if we change this to 5, then automatically this should change to 5 feet as well, but let's not go into that detail yet. Now here I'm going to find out what is the movement at this particular distance. So in order to find that, we need to use W, and the formula for distance, I'm writing it here, is W into length. So once you multiply it with, it's the total load, and in order to find the reaction, we will divide it by 2. So W into L is total load, reaction is WL by 2, and multiplied by distance x. So you will multiply it with x. So we'll get the moment at this particular point at a distance x, for example here, uh, due to reaction. But also we have this load that is going to cause or reduce or induce further movement. So that will be in opposite direction. This movement at x is in clockwise direction, while at x the movement of this portion of W will be anti-clockwise. So we'll write minus here, and after minus we know it is further this total load is WL. So I'll write W into L, and then the and its movement arm is from the center of, I'm sorry, this should not be L, this should be X. So because the length is X here, so from the center the movement at this edge is W X, Wx into the distance is x by 2. So it will be further multiplied with x by 2 as the movement arm. So this is the movement arm of this load, but negative because it is anti-clockwise, and this is the reaction, and reaction multiplied by the movement arm, which is complete x. So this formula can give us the bending moment at any distance x, and we have so many x here. So let me click here and write this formula. So once I'll start writing the formula, as I already told you, we'll start with an equal sign, and then we'll we need W. Now where we already have taken the input of W is in this sheet, so keep writing equal here, and we change the sheet and select C2 because here we have written W. Notice in the formula bar it is saying that after equal it has written go to the lintel beam design sheet and bring the value of C2. Now single quote and exclamation marks are important, and it is automatically written by Excel. Now once I'm here, I can start clicking here and continue with the formula, or maybe I can go back to the BMD sheet and I can click here again and carry on with the formula. So for now the formula is equal to this. Now I need to multiply it with the length, so I'll multiply it with the length going back there, and I'll click here. So now it is saying C2 in lintel beam sheet, multiply it with C3 of the lintel beam design sheet. I go back to the BMD and see we need to further divide the result by 2, so I'll say divided by 2, and then we need to multiply it with this X, so I'll say multiply with A2 in BMD sheet. So I click here and you can notice here that it is already automatically changed to BMD sheets A2. Then after this we have minus W again, so I'll go back to lintel beam design, click on W, so automatically it is entered there as well, and then multiply with X 2 times, so I can say multiply with X, and instead of writing multiplying it twice again, I just do shift 6 for caret, which means to the power, and I make it 2, so it is to the power 2, and then further it is divided by 2. So in order to, it will work fine because I know that the precedence of these arithmetic symbols is it will take powers first, then it will multiply, then it will divide everything, then it will add everything and subtract everything, and this is how it will do. So this formula will work fine, but let's close all these things in parentheses, so it appears that things are going okay. So this is the power of the product, this is the power of this, and it is then further divided by 2, but I know this formula will work fine without these parentheses as well, but I just closed it to be safe. And then this whole, if it's not needed though, but then you can close this separately, and you can see that the parenthesis color is telling us that this is the opening and closing of the red parenthesis, while this is the opening and closing of the gray one. And then we can also close the other first section in parentheses if we want, and again we may not need it. Now if I press enter, it should give me a result, but it's saying there's something wrong in the formula. Let's double check. So we missed the name of the cell here. We had to divide, before dividing by 2 it had to select the length and the C2. After C2, let me delete this portion, and we know it should be multiplied with length. I go back there and I click on length again, so now it has written length after asterisk here for me, but before the divided by 2 here, so it's fine. Now I press enter again, so the bending moment at distance 0 is 0, and we know it is because it is a simply supported beam. Now we have already given a lot of effort in writing this formula here, so we need to write it for every one of them, but then we actually don't need to do that. Now I'm going to follow a step of copying this formula by clicking this box here and dragging it all the way to 10 here. It is going to copy it, but it will give us wrong results for some reason. Let's see that. So it is giving us not a parabolic shape. It is obvious from these numbers, so many zeros at the end, and the reason is, notice that here in this formula it is multiplying C2 with C3 in lintel beam design sheet, which is W and L. Let's check that. So C2 is W and C3 is length, so which is fine, it has picked them correctly. But then once we drag this formula to the next row, it copied C3 and C4 from the lintel beam design sheet. So if we click there and we see that C3 and C4 are actually not W and L, but they are length and D, and we don't want to multiply length with D. We want to W and L to be keep multiplied there. So in order to fix all these in dragging it, what we do is we fix them by dollar sign. So I'm saying here that if now I already have a mistake, I've selected a wrong cell here in multiplication, which was actually W in not in this sheet but in the previous sheet. So let me correct that first. So I delete this portion from here, and here we need to, before squaring x, we need to multiply it with W. So let me go back in Lintel design beam sheet and select W here. So now W, which is in cell C2, has been selected here. Now in order to fix this W, said when I drag this formula, it should remain C2. I should write a dollar behind column C. Now whenever I drag the formula, it will always keep C fixed. Also I fix 2 by writing dollar here. Now whenever I'm going to drag that formula, C2 will remain fixed. Notice here W is not fixed, but here W is fixed by dollar signs. So let's see what will happen to the formula again. So once I press enter here, I automatically go back to the place where I entered the formula, and now if I drag it again, you will see some changes there. But see here, C2 and C2 was used, but this was fixed. If I select the other cell and check, it has been converted into C3, but then this remains to be C2. It is fixed. So it is a reference formula. It is referenced with the position of the new cell, while this is fixed. So let's fix all of them in the previous formula. So I want W to be fixed, so I dollar and dollar, and I want L to be fixed. So if you quickly want to apply these dollars, you just select the formula and press F4 on your keyboard. It will automatically apply all dollars. But if you want to do only column or row fixing, you can keep pressing F4 and it will keep changing dollar for you by fixing nothing, fixing all column and row, fixing only row number 3, fixing only column number C, and then fixing nothing, and then back again. So we need to fix it. X we want to vary, but X is not in any other column. So let's fix the column of X by writing dollar behind A. Now row is not fixed here because we haven't written dollar behind row. Similarly in A2 here, I'll also fix the column, and I cannot drag the column now, but only row number will change. Now I'm okay. I press enter, and now instead of dragging it now this time, if you double click on this, it will also copy it automatically to the bottom. And now it seems it's working very fine, and the at supports, because it's a simply supported beam, we are getting the bending moments of magnitude 0. Now the middle of the beam is at 2 feet, and we know that at midpoint we have the maximum bending moment as the parabola shows here as well, and this is what we see as well, which is the maximum number from here. So why not pick the maximum bending moment from here and use it in here? So let me write here M max. This time I'm not subscripting it, but you can subscript it if you want. And here I'm writing equal to max, which if you notice, whenever I write any alphabet here, a list of formulas that starts with A will appear, and these are all available formulas in Excel. With Visual Basic for applications, we can write our own formulas too, but these are available already in Excel. You can also click on this FX to select the formula from different type of categories. For example, financial formulas, statistical formulas, trigonometric formulas, and so many others. But let's leave it for your own exploration. Let me cancel this, and let me write is equal to max. Now if I use any other name beside these, they are not accepted as formulas, they will give us error. So always it should be the name available in the list. Then I open the parenthesis, and it says that give me a list of numbers separated by semicolons, and eventually it will find the maximum among them. For example, the maximum of 5 semicolon 1 semicolon 9 semicolon 3. Now in old versions of Excel, instead of semicolon, it shows comma here, so use comma if you're using old version. So I close the parenthesis and press enter. We know the maximum is 9 and the result is 9 here. We can also write equal to maximum, for example. Now I press escape, and then if you want to edit the formula, you can double click it and it will bring the formula back to you. Or oppositely, I am escaping it now, you can click and go here in the formula bar and you can change the formula there as well. So whatever is easy for you. So let me, instead of this, write equal to max, and in parentheses I select a range here. Find me the maximum number in this range, and notice a range is shown by Excel with a colon. So colon means starting from C2 to C7. Now if I select a range like this, at the bottom it is showing there are 8 rows and 4 columns in it. So if I select this range, and you can see now it says starting from C2 all the way to 59 F9, all these cells, find the maximum anywhere in these cells. But then for now, let me select all these and close the parentheses, and it's obvious that 60 is the maximum, so it should give me 60. But here we need the maximum of the bending moment, so I'll write is equal to max, parentheses open, and I go into bending moment diagram sheet and select all the bending moments and maybe some extra cells for future, and then I close the parentheses and press enter key. So it is giving me the maximum bending moment here. I know the unit here we decided was kip fit, because carefully we used kip and feet for length for W and L. So here I'll write, just for my understanding, I can write kip per fit, but I already used it here, so why not, let's salvage it here from there by, I'm sorry, the unit of bending moment is kip foot, not kip per foot, so we have to write kip foot. Perfect. We can do another thing which is called naming cell. So what we can do is we can name this cell as W by selecting it and typing here W and enter, and then once you click this cell again, you will see it will be named as W. But then the next cell is actually C3 is its address, which is already written here, but you can actually select this and call it capital L and then press enter to it. So now they are named cells, and we can find out, we can use these names in our calculation. For example, if you want to find the product of them, which is the total load on the beam, which is W into length, so you can say total load equals to, and let me full width it, and then we can, instead of writing equal to this multiplied by this and showing actually C2 and C3, they will be simply W and L. So if you just simply also do equal to W into L, now they are already listed here as available and they will work fine for us. And now if you are interested to remove these names from these cells, what you can do is you can go back to in the menu in the formulas, and if you um, go in formulas, you will see there's a name manager. Click on name manager, these names will be available there with their values. You can just simply select them and delete them. For example, let me delete this. I show you want to delete, I say okay to this, and if you want to add new ones, you can also add new ones from here by writing name, for example D, for the cell which is not G6, but actually I just delete that and select this here, and I say okay to this, so it will be added in it too. So let me close this now and C, because we wrote we removed that name L, so it is giving us an error. But if instead of L we just write W, which means nothing, W into D, but then it will get multiplied like this. So let's go in BMD, and we actually don't need this formula now. I just wrote it for your reference, so just for the reference of other people who are going to use this sheet, if you want them to know how you calculated bending moment, so we can write here bending moment is calculated equal to this. So it's just a text, so for future reference it will be just mentioned here for people who want to see how bending moment was calculated. Let me draw a graph or a plot of this bending moment diagram. So in order to do that, you just select them all. Let me and then in the insert menu, from the insert menu you will see there is a section for charts. There are several types of charts you can draw, and you can select them from drop down of scatter type here as well. If you want to draw bars of different types, you can do that. If you bring your mouse, you can see a preview. We don't want any of these types, so let me select on the histogram and see how it shows. We don't want that as well. What can help us is one way is by line, but in x-axis it gives us some wrong information. You can see on x-axis it is showing from 1 to 9 because we have actually nine data points here, but we want 4 feet, up to 0 to 4 feet should be shown there, and that type here in Excel is XY scatter type. So we just select from here maybe only points. Now you can see on x-axis it is showing me a beautiful parabola from up to 4, and then we can draw in this format. We can draw different types if we want, whatever we like, but then let's choose parabolic, beautiful parabolic with points, and let's play with it. So once we have drawn this graph, I want more beautiful formats in it. So if you select it, and you just click on chart styles, you can see the different available styles. You can double click on this to see editing menu on the right appearing like this. Now once you select this chart, it will show the possible editing in it. So for example, it's showing me an extra foot here. I don't want that. So in order to do so, now because on the x-axis I want it to not show the 5, I click on the axis, and once it gets selected like this, it will show me the axis options. So if you select the vertical axis, you can now edit the vertical axis here. If you select the plot area, you can now edit the different properties of plot area. For example, its background solid its border, and then if you want to fill it with some background color, maybe light blue color, you can do that. And now currently I want to play with the axis, so once I click on it on the axis and it gets selected, I can click on the axis options, and then in the axis options further I can say the minimum is 0, which is fine, but maximum is 5. Instead of that, I don't want it auto, I want to fix it to 4 feet, so I select 4 here, and then once I select it back, you will see it is limited to 4 feet now. If I want subtitles, access titles here on here, I can use quick layout from here to add some variety of title options and styles to it. But then if I only want titles and individual items being added in it, I can click on add chart element, axis title, primary horizontal. So you can see x-axis title appears here, and again axis titles and primary vertical. So we have vertical axis title here as well. So here I can write, I can select it, and I can write distance, and in parentheses of course we must write units in feet, and similarly bending moment and in parentheses we can write kip foot, kip feet. So we have seen how we can draw graphs, we can edit them, we can change the size. There are so many other elements you can bring in. For example, if you're interested in legend, which tells that what does this mean, you can then also select it and move it in some better location, and then make chart as beautiful as you want. You can play with it. So many settings can be done in this. You can even change the title if you don't like this to be used as title here. You can write bending moment diagram of lintel beam. Change the font size, perhaps select all, home, and font size, reduce it to any you like, then drag it to the top. Let me change the background color to white. Let me also select this and change it to a solid line, but black in color. These dots, if I want them as marker of the shape built in triangle, which is not not filled. So sorry, I changed it in the legend. Let me delete the legend. So I just changed only one marker by mistake. So in order to select change all of them together, if you select them once, uh, all of them are selected together, and now you can change them. But if you select click any of them again, only one is selected, and then you can change the shape of only one. But let me select all again and quickly change the marker to built-in triangle again, and then increase its size, for example, and then no fill in it, for example. So if you like it to be shaped like this, or maybe no fill, and or if you select them back again, actually I changed the fill color of no fill in the background of the chart area instead of triangle. So I select the chart area again and solid fill it with white, while I select the triangles again and I go to marker, and actually I say, for example, no markers at all. So this is much better for me, a beautiful bending moment diagram, and we can then use it for other purposes too. So let me close the settings and now go back to our design side, and here let's figure out the design, which is to find out the area of steel that can that has the ability to resist the bending moment of two kip fit that is bending and trying to crack this beam at the bottom. So we need to find out that area of steel at the bottom, AS, that can actually resist that amount of bending moment. So in order to find that, let's rearrange all this, and if we do that, we will notice that we will have an equation which has area of steel on both sides of the equation. So now in order to calculate the area of steel that is required in this bottom portion of this lintel beam to resist the tension, I rearrange this equation and I realize that it is an implicit equation where we have area of steel on both sides of the equation, and we cannot solve it directly. So let's see how we can use the power of Excel to solve this formula. So from here, first of all, let me copy this formula and just paste it here for my reference, so that I need not to go back to that document again. So here we have an image of that formula, and we can increase its size, we can reduce it. Right, so let me try writing this formula here, which is equal to the bending moment in kip fit. Because area of steel is in square inches, we need to convert this feet into inches by multiplying it with 12. Then we have divided by in the parenthesis, divided by within the parenthesis, we have phi and fy first of all. So phi multiplied by fy, and we make sure that units are in kip and inches, and we also have movement in kip, and we already converted that into inches, so it is fine. Then we need to further multiply it with parenthesis closed d in inches, it is in perfect units, minus now as. So instead of picking up this as from here again, which is a cyclic formula, it is not possible. So for now, just temporarily, I select a cell maybe here, and I memorize this for now, that C14 is a trial value of area of steel, that I'll try to bring it equal. Let me continue with this now. So now this AS multiplied with FY, which is 60 again, and then divided by 1.7 multiplied with FC prime, which is in correct units, and also multiplied with B, but then all this should be within some closed parentheses because they are in denominator, and then we have to close this red parenthesis here, and then we also need to close this black parenthesis at the end here again. No other parentheses need to be closed. We are ready to press enter, but remember C14 is blank, so it should give us some error. So here it is a wrong answer. So let me put some value here as 1, and we have this particular result here. Now let me say I copy this from here and I paste it here, and then I change its name to be trial. So here we are writing a trial. So what I'm saying is that if the value here in this formula, if the value here is 10, we know that area of steel is 10 units, then AS is 10, this means this should also be 10. If this is minus 5, this should be minus 5, because AS is same as AS, so they should have the same number. So once in this formula I put AS is equal to 1, it should give me 1 here as well. This means this is not the correct value of AS, and because it is small and we need to increase it to give this value, let me give it a trial of 3 for example. Now you notice it start to increase now. So let me make it 5 and then 10. So it's now negative. So it is a very hard thing to do. Let me start reducing it to 0.6. So now it is getting closer to 0.6. Then I'm changing it to 0.3 for example. So it's closer now. So an easy way of doing manual trials is that whatever number is written here, feed it back in, for example 0.04, then it gives you an error, how much the error is in between, then you correct it by 0.037, writing the same number once again, and then with 2 trials, I'm sorry, I just wrote it in a wrong location, it should be in C14, so 0.037199, and then now we are very close. Let me repeat, copy this and write it here. So now it is perfect. This means if you put AS is equal to 0.037188 here, it gives you 0.037. So this is the correct value. But let's learn how we can do it automatically with Excel. So in order to do that, we, after writing this formula here and putting this formula here and putting the trial value somewhere on the sheet, maybe here like this. Now what we can, another way of checking this is to find the ratio of the two. So for example, if I say here ratio or trial ratio for example, now if I say this is equal to this divided by this, Now whenever this value will become 1, this means this is equal to this. You can also say this is equal to this minus this. Then our goal is that whenever this value is 0, this means this is equal to this. So there are so many ways of playing with it, but let me try with this divided by this. So this is our goal, that to convert this value of G11 to 1. So if this is 1, this means both are equal. So let's try with the same value of 0.037188, and yes, it's almost 1, so we are okay. So this is one check, but let's do it automatically. First of all, let me put a random number here, and it can be 1, it can be any random number, maybe 10, doesn't matter. So let me write 1 for example first of all, and then in I go to the menu of data. In data, in the forecast, we have what if analysis. I click on what if analysis and then click on goal seek. And then goal seek, we need to set a goal in a cell. So it is G12. The goal is, sorry, G11. So I can write G11 here, or I can click here, and then it will ask me click where the cell is where you have a goal to see a set cell to where you need to seek that goal. I select this, and because of course I need to clean it first and then select this. You can also do that. You know what dollar means, it fixed this cell, and then we need to seek its value, which is equal to what? To 1. We are targeting 1. It is almost, it should be equal to 1. Then stop seeking the goal. The goal has been achieved. By changing what cell? We know we were changing this cell by putting some trials. So either write C14 here, or just click this button and then click the cell where we are changing the values. And then now let's click on OK and wait to see it done automatically. So I click OK, and then it is trialing, and you can see the current value is almost 1, and it reached to this particular trial, which is not as close to as what we achieved, but then yes, we have actually achieved the correct answer in the yellow box here, which is 0.037188. So let me try that once again by starting from a random value of 1000 here, for example. So I do repeat the same by in the data, in forecast, what if analysis, goal seek, the set cell value here, this cell we need to set it to 1. Once it is 1, the goal is achieved. We set it to this value by changing what cell? By changing this cell, which is C14, and then I say OK again. We wait and wait and wait. It was not a very clever starting value, so we know we have to start from some better number. It is 0, very much. This means minus 8.5 into 10 to the power minus 65. So the trial start was not a very good number. Let me try with 0.9, for example, and then let's repeat that. So what if analysis, goal seek, set cell this to value of 1 by changing this cell, and OK. So again it gave me the same answer here. It worked this time, and it is now very much close to 1 as well. So with this example, we have learned another advanced feature of Microsoft Excel. So what does this area of steel means? It's also important to know. So let's discuss this quickly. So if steel this steel is available in the market in the form of deformed bars. These are Tor bars because they are twisted, but let's not talk about that. These are deformed bars. They are called deformed bars because they have deformations on the top, and here the diameter of these bars is mentioned, 8 mm all the way to 40 mm. Here there are many other sizes available, but these are the standard sizes available in the market. In metric system, this millimeter size is written with m hash to write the number of bar. So in parentheses we have millimeter system, outside parentheses we have inch or FPS system. So M#10 means 10 millimeter diameter bar, and in FPS system in Pakistan as well, it is called 3 number bar, or it's also known as teen sutar bar in local language, and the diameter of that in inches is 3 divided by 8. So if it is a 20 bar, which is not listed here, so let me say 16 bar, for example, as in the picture here. So it's actually a 5 sutar or 5 sutar bar or 5 number bar, which means its diameter is 5 divided by 8 inches. Now we are interested in square inches area. So in this figure we can see a labor working on tying a stirrup with these vertical 4 bars for this column. So just to give you an idea, this bar here is around number 3 bar, and here is about number 5 bar. So we can see, we can now guess the sizes of all these bars, how big this is and how small is this one. So we know that in market when we purchase these bars, they are not purchased by the area as we have figured out in this formula here like this, but we actually purchase them by the not by the area but by the size of the bar here. So let's find out how many number 3 bars we need for this particular design. So here in the cross section area, we know that number 3 bar has the cross sectional area of 0.11. So what I will do is I will make this table here. So I'll say or I'll simply say bar number, and this is equal to this divided by 0.11, and then here I'll write number 3 bars. Number 3, and here I'll write bars. I don't need this trial here, so I just drag it at the bottom here, trial ratio, and it will still be used the same way as before. We can increase the size of the columns and rows like this, but if you want them to be arranged exactly as the size of the text in it, you can by instead of dragging it, use double click here. It will fit its size to the maximum size of the length of the text in it, for example like this. So if it is large, it will become smaller, and if you make it smaller than the largest of the text and double click, it will arrange it to the largest size of the text, which is the trial ratio here. So now we already divided by 0.11, so we need 0.3 bars. Very less bars are required because the load applied was too small. Let me increase the load to 10 kg per foot and see how much area is required. So now this time we need the area of steel required at the bottom of the beam is 0.371, and how many number 3 bars are required is 3.38. so this we can buy 3 bars, but we cannot buy 0.38 bars from the market. So let's round it up. So I select this, and in this formula here I say round up, and I close this in parenthesis. I have an option to write number of digits, how many decimal digits I need, and then I can write with a semicolon 0 here and then press enter. So it is now rounding up. So now I need 4 number 3 bars at the bottom. So number 3 bars at bottom. So let me write here as at bottom. So in our design, so let me right click on this row and say insert to insert a blank here, and I want to clean this format. One way is to just drag another blank on top of it, or maybe just undo that, or just change the color from home back to no fill. So I just simply drag on it now like this, and I give it some title, for example beam lintel beam design. So, and I just select all these cells and I merge them, and then I make it bold, and I select all these and I um, just give them a outside thick border. So this is our lintel beam design at the end. uh, Now I want that if I select the bar style here, automatically it should divide it by the area of that bar, and then give me the bar number there. So I can do that by creating a table anywhere else. So let me create a table here. For example, I know that number 3 bar has the area of um, 0.11 square inches. So let me say bar number, and then here I say area in inch square. I'll change the format later, and then I quickly um, write a few numbers from here, not all of them, just for demonstration purpose. So I write number 4 and number 5 and number 6, number 7 and number 8, and area is 0.2, 0.31. I'm just picking them in square inches, in square inch areas from here. So 0.44 and 0.6, and finally 0.79. So now I've created a table for me, and I want the ability to be able to select these bar numbers from here. So what I'll do here, I'll just click here. Once I say, instead of this, I will go in data, and then in data tools I'll have this option for data validation. I click on that, and in it, instead of allowing any value, I would say allow a list. It will ask me where is the source of the list. I can click here and select this all range. Automatically from J2 to J7 is selected. Now I say OK to this. I allow ignore any blank values. If anyone write blank here, I don't mind that. And there should be a drop down button in the cell, in this cell. So I keep that checked as well. There is an input message and error message on it too if you want. If someone put anything else beside these, it should give error. You can check, you can do these settings, but let's not do that now and say OK to this. So now if you see, if you click here, a drop down appears here, and now you have the ability to select bar number. But it is just, what we did was we just created a list of this available here. It is not working, it is not changing the number of bars for us. So in order to do that, what I will do is I'll write a formula here. So instead of in rounding up this divided by 0.01, I want that whatever number of bar we select in that particular cell, its area from this column should be picked here. So what we are doing is we are vertically looking up for a number here and getting a value from a corresponding column here. So what I will do here, I'll say, instead of writing 0.01 here, I'll say we look up. So you can see there is a existing formula for this. We look up, and in parentheses, blank parentheses, I'll start selecting what it's asking me. What value we want to look up? We want to look up whatever is in that cell. So instead of writing here, let me start writing here to be more, the things are visible here. So I'll again write we look up, vertically look up what we want to look up, the value whatever is selected here. With semicolon, it is asking us, let me close the parentheses already here and then start working inside it. It's clean work. So this value is the value we want to look up, semicolon, in which table we want to look up this value in the first column in this table. So in this table, I want to look up in the first column the value selected in the drop down from here. Then with semicolon, I need to put two more things in it. So with the semicolon, automatically you will see the next value will get bold. I know what I'm putting in. So with semicolon, what column index to bring the result from? I don't want the result from the first column, but I want the result from the second column. So I'll select 2 here. And then the last value with the semicolon, the box bracket means it is there is a default value in it too. If you don't give its value, no problem, but if you want to give value, you just write a semicolon and it give you the option that by default it is true to be approximate, but then we want exact. So let me write false here, or just double click from here, so it will automatically write false for me, or I can type FALSE here as well. So now we have written a complete VLOOKUP formula here, and now what it will do is it will divide C10, which is the area of steel, by the value we look up in this table J2 to K7, first column. In this table's first column, we look up whatever is in the red cell, which is D17. So whatever is selected here, which is, for example, number 6, so 0.44 will be picked up from here, and C10 will get divided by 0.44, and then the whole result will be rounded up to the largest value without any decimal place, because we select 0 here. So let's press enter and see what we get. So now with number 6 bars, only 1 bar is enough, but if we select number 3 bar, so we need 4 number 3 bars at the bottom. But if we select number 4 bar, so it will give us 2 bars are enough. So whatever is cheaper, we'll select that in this design. And this is how we can use Excel in civil engineering for some advanced type of calculations. So Excel is basically a calculator, and what we have done is we have actually created a small program. So it is a programmable calculator, and if you notice, in a calculator we always have one cell in which we type something and it works, but here we have a two-dimensional calculator of a huge size, but not two-dimensional. We have a sheet over another sheet, and then that can be over another sheet, and that can be over another sheet. So it is actually a three-dimensional programmable calculator. So what we can think of Excel is a three-dimensional programmable calculator. Let me hide these because we don't need them, by selecting these two columns by again clicking one column title and then dragging like this, and right click and hide. So this double line will identify there is a hidden column. Also by names we can identify. So after FGHI there is no J and L. This means there are hidden columns here as well. We also notice that by changing this 10, the ratio is wrong, so it should be 1. So once it was 1, the ratio was okay, but now this is wrong. If we change it to 10, the area of steel trial should be, the ratio of them should be 1. So we need a warning here as well. So what I'm going to do, round up this value as well. So it be round up to a 0 decimal. So I'm, instead of writing semicolon, I wrote comma, so it gave me error. So I'm writing semicolon because in my version it is semicolon. In maybe your installation it may be comma, but be careful. So it should be 1. So now here I'm writing a check, and check is if, so after equal sign I write if, so you can see it is available. If this is not equal to 1, then it's saying, this is the logic we put. Then after semicolon we are going to write if it is true what to do. So with semicolon, what to do here is I'm writing in inverted commas, do goal seek again. So it is giving me warning. And with semicolon, if it is false, which means it is actually equal to 1, it is okay. So I'll just say simply write check is okay. So now if it is, if I change it to 1 for example, so it is giving me 2 because it is actually rounding it up. So instead of rounding up, we'll just simply round it to 0 decimal place. So I just delete up. So we just do simple round. So now it is giving us perfectly fine 1. Actually, it is not equal to 1. Let me show you some decimal places. For example, 5 decimal places. You will see actually it is not equal to 1. But with round, we round to 0 decimal place, we convert it into 1 so that our check will start working. So now what happens is it checks that if this value is not equal to 1, show this statement, but if it is equal to 1, show okay. So now let me press enter. So if it is equal to 1, it's showing okay, but if I change it back to 10, it is giving me a warning that do goal seek again. So what I will do now is, of course, I know now that go and click on data and then go in what if analysis and then goal seek, and then from here the set cell will be trial. We want to set it to near to 1, and then by changing what cell, by changing the trial here we do, and we say okay to this. So yes, now it is ratio is 1. We have almost similar trials. Let me say okay. So the last value that worked was this. Now we have a big error here because we round it to 1. Actual value here should have been this, which is very big difference. So this is not a good place to round it. So let's round it to here. So what I'm doing here is I'm saying round, first of all round whatever is in C16 to 0 decimal place, and then check it, is it equal to 1 or not, is it not equal to 1 or equal to 1. Or let me change it in a forward order as well. If it is equal to 1, then write okay, else write do goal seek again. So now it is fine to keep it like this so that not big errors appear in this form. We don't round it to 1. So this time let's goal seek once again. What if analysis, goal seek, we want this value to be set to 1 by changing the value of this cell. So okay, now we can see it is very close to 1, so say okay to this, and now it is also saying okay because actually it is rounding it to 1, and then it is checking yes it is equal to 1, so it's okay. Now because it is a warning, I want it to be highlighted well. So let me select this and I do automatic formatting of this. So in home, after selecting this cell, we go to conditional formatting, and from here we set a rule, for example highlighting cell rules, that if it is equal to okay, so format, we want to format this cell to if it is equal to what, okay, and once it is equal to okay, it will get formatted to light red color fill with dark red text. I don't want that. I want green fill with green text because it looks more greener, and I say okay to this. So now this will automatically start giving me warnings of different types. So if Now I change it to 1. It just don't show that green to me. But if I change it to 10, and it tells that I need to do goal seek again. But if I change it to 10, so it now tells this is okay. But I want that if it is not okay, for example like this, it should show me a red color symbol here. So why not let me click again and set another rule that highlight this. In more rules, we can say that if cell value is not equal to okay, then what format we want? We click on format. We want it to be the same font but bold. We want it to be filled with red background. Okay to this. So this is how it will appear to us. So let me say the foreground color to be much yellow, for example. So let me say okay to this now. So it's like this. Let me increase the size of the font as well, but it's fixed here for some reason. Let's say okay to this and then okay. So now because it is moving to the other cell, the filling is done only in the cell we selected, but then text is allowed to appear on the other cell until you write something here, so it stop appearing in the next cell. So because it's a large, it can be a larger text. So let me select a longer length portion and merge them into a single one. So here, if once it is not okay, it will show me a warning. But if I change it to 10, for example, if it is okay, show me green one. So now it is very visible that if I change anything, for example, the depth from 12 to 9, it will it should not be matching. So it should start showing me to change it. So we know that it is very different and it is not working well because I actually round it to 0 decimal place. So let me at least round it to 1 decimal place. So now if it is 1.0, only then it will show me okay. But if it is anything else, it will show me wrong. So let me change it back to 12. So it is almost 1.0. That first decimal place is equal to 1. So the 1.0 is equal to 1. So it says okay. But if you change now anything else, so it is, starts giving you warning. Now again 0.98 is this is very close to this, so it's okay. But let me change it to still both of them are very close, so it appears fine. But then let me change it to 12, for example. It's still 1. Okay, so now it's rather big difference. So it's still close, but then difference is more than what we require. So it is saying we have to do retrial. So let's do it once again. For example, for very poor concrete, which is not allowed actually in construction, but anyways, just for learning purpose, let's go to goal seek. We set the value of this cell to 1 by changing the cell this one. So it will start trialing on this and achieving 1 here. So let's say okay, and it is achieved. Okay, so slight change. Another important thing is to how to write CSV files or comma separated value files. We used in Python as well. In order to learn that, we will convert this table that we have drawn with some text maybe written here, these two, into a CSV file. Note that CSV file is comma separated values only, or tab separated or space separated values, and it has no graphs or formatting. So if we have made this bold and this italic, for example, and then change the background color of this and then make this red, and but I would maybe close this in whole big border and then apply maybe some other general borders to this one. So all is it looks like a very much formatted table, but actually CSV file will be nothing more than these values, all these written with some separated commas or tabs. So how to save that is, notice currently I've saved this file as lecture 9 xlsx file, but if I say to this sheet, BMD sheet, to file, save as, uh, lecture 9, but then let's say CSV, this is comma delimited one. There is another one with Mac or MS DOS as well. There is another one with UTF-8, but then let's not go and talk about its details. Let's click on the same UTF-8 format, and then so it will be now this time saved as lecture 9.csv file. If I click on save now, it is saying that it is going to clean all those it is not going to save the whole workbook, but the only this sheet will be saved, not the Lintel Beam design sheet, but only BMD sheet will be saved. And if you say okay to that, it will be that, and then no formats or names or other things will be also available in this. So let's see what it produces. So notice the file name is now xlsx, but then if I say okay, it becomes CSV. And if you click on this one, it is still showing the name of CSV. This does not mean this is the same file. Actually this is xlsx file, but currently it is showing, it is keeping the backup, it is not wasting your work here. It is already saved in xlsx file, but then currently what it's saying is that now you have if whatever you save will not be saved in all these styles, but only text. So let me open now again the XLS file. So here again, if you notice, this is the XLSX file, while separately the CSV is shown here behind, but then this is not how actually CSV looks like. Let me close this CSV. So I open this is XLSX, and let me bring the CSV on the screen. So this is CSV file. I close this. So now I save, it's already saved, so I just say I don't save any further, and let me go in the folder and see how it actually looks like. So here we have this CSV file. I actually open Notepad and drag it in it first of all to show you the separate comma separated CSV file, but this is not comma separated, this is actually semicolon separated here. So because we used data which has first column used, second column used, and third column blank, and fourth column used with certain values, so that is why we have first column, second column, third column blank, and last column with some rows filled. For example, the second row was filled with this statement, and the fourth row, third row as well, but rest of the rows were blank in the last two columns. So this is how CSV file is. But if I double click on it now and open it in Excel, you will notice that all those graphs and then formats will be gone, and it is just simply text. If you format it and uh, try to save it now as CSV, so you will notice that it appears that it is formatted, but actually if you close it and open again, it has no ability to save formats, and it is merely a text like this. So be careful, you don't waste your time in formatting CSV files. They are just text files, as we have seen in Notepad. So in today's lab, I want you to write all this sheet first of all again, and then create another sheet, not by name of BMD, but by the name of shear force diagram, or SFD, and keep the axis same, but instead of bending moment here, figure out a graph of shear force. And we know the formula of shear force is calculated as um, how we can calculate shear force is that the reaction here, which is W into L by 2, so it is W into L by 2, and you subtract what from it? You simply subtract, for at a distance x, the W times x got subtracted from it, simple as that. So W times x. So this is how you will calculate shear force, and then you just draw the shear force diagram as well. And additionally, you have to do the bending moment as well as the lintel beam design sheet all together, with all the things that we have in it, and try to make it more beautiful, more different arrangements of all these, better way of representing the design, whatever you like. You may or may not need the formula here, or maybe you write it in your own way, how you want to write it, where it is needed, for example. So best of luck in your today's lab.